Children, next goes to question number 13. The tendency of BF3, BCl3, BBr3 to behave as Lewis acids decreases in the sequence. So here, what are given? BF3, BCl3 and BBr3. In this tendency, which is more Lewis acidic nature. So according to Lewis theory, what is an acid? The substance which is accepting of electron pairs from other substance, it behaves as Lewis acid. So now here BBr3, we are accepting of electron pairs more. Next here, which one is correct? BCl3. Next one is BF3. But actually, it expected as here BF3 molecule. Why? Because here is a small size of the atom. Because boron is surrounded by fluorines. Here chlorines, here bromines. Bromines are large size. Available of space is less. That's why expected as here BF3 is a more tendency of accepting of electron pairs. But whereas in BBr3 molecule, here boron atom, here is more tendency to accepting of electron pairs. Why? Because here fluorine surrounding, due to lone pair repulsion, that's why it is not ready to tendency of accepting of electron pairs. Therefore, the BBr3, BCl3 and BF3 is the tendency of water for accepting of electron pairs. That's why here option B is correct, children. Next 14. In which of the following arrangements is given the sequence is not strictly according to the property indicated against case. Here see, children, we are given various orders with respect to property. So now we are asking not strictly according, here which is not correct. So first option is given HF, HCl, HBr, HI is increasing of acidic strength, correct only. Because of stability, what happened here? HF, HCl, HBr and HI. This is the correct order of acidic strength. Correct only. This is A given. But what about B are given? Here pK values. H2O, H2S, H2Se and H2Pe. This is order of pK values here. You know, pK values is indicate the acidic nature. So what is the relation here? pK and acidic natures are inversely proportionals. So higher the pK, less acidic nature. So your acidic nature is what happened? Your hydrates, any group increases because of the last hydrate is a metallic hydrate. This is unstable, readily producing the protons. This more acidic nature means here less pK value. But it is not less pK value. What happened? Your pK values are increases. pK values are increases means understanding least to acidic nature. But it is not least acidic nature. It is more acidic nature. So that is why the order of pK values are wrong. So you are asking which is not correct thing. That's why you can choose option, children, here. B option in 14. B. But remaining salts observed here. Remaining hydrates are given. C option. NH3, PH3, again ASH3, next to SPH3. So these are also hydrates of 15th group elements. But here also what happened? Hydrates 15th group elements acidic nature increases only. This is also correct. Whereas next is given, B option is given CO2, SiO2 and SnO2 and PbO2. These are all 14th group elements of oxides. So, what happened here? Oxidizing power increases only. Oxidizing power increases. Because of here PbO2, oxidation number of electrons is plus 4. So, oxidizing means sulfate undergoes reduction. So, here this is oxidation state is plus 4. And that means one more is also possible here, Pb plus 2 also. Which is stable form? Pb plus 2 state is stable form due to inert pyramid. That's why Pb plus 4 is sulfate undergoes reduction. But it acts as here oxidizing agent. So the oxidizing power is what happened? Increases. So this is also oxidizing power order is correct only. So and finally, which is wrong? Option B is wrong, children. So that's why we are quoting here. Which question here? Question number 14. Your option B is correct. Next children, 15. Acidity of diprotic acids in aqueous solution increases in the order. So same here also. Acidity order in aqueous solution. What are given? H2S, H2Se, H2Te is given. So which is more acidic nature? H2Te is more acidic nature. In aqueous solution, here which is more acidic nature here? H2EPA. It is decomposed to formation of H plus ion and here H minus. So that is the correct answer. 15th one is A children. Next, 16th. The formation of the oxide ion O minus 2 from oxygen atom requires first an exothermic and then endothermic step showing below. So what is given here? Oxygen plus electron gives rise to O minus. In this case, standard enthalpy of formation value is how much? Minus 141 kilojoules. But whereas the secondary option, O minus plus electron gives rise to here O minus 2. In this case, standard enthalpy of formation is given as 780 kilojoules. So first reaction what happened? Here gain of electron. This is first enthalpy. Here this is called here electron gain enthalpy. Electron gain enthalpy of the first electron minus this exothermic. Second electron gain enthalpy becomes positive. So the second electron onwards, electron gain enthalpies are positive. First electron gain enthalpy only negative. Why? Because so here accepting of electron is there. First electron. Whenever addition of the second electron, in between first electron and second electron starts the repulsions. Then to overcome the repulsions, to give some amount of energy. That is why the second electron gain enthalpy onwards are all positive values, endothermic process. But only first electron affinity is or first electron gain enthalpy is negative children. So now in this process, the formation of O minus 2 here gaseous phase is unfavorable. Even though O minus 2 isoelectronic with neon, it is due to fact that which is correct here. The process of formation of O minus 2, which phase is there here? It is a gaseous phase only. Unfavorable, even though O minus 2 is isoelectronic with neon. So O minus 2 means how many electrons here? Oxygen L2 plus 2, total 10 electrons. 10 electrons means which is element? Neon configuration. Neon is a stable configuration, but not favorable, O minus 2. So what is the fact here? Due to electron repulsions outweighs the stability gained by achieving the noble gas configuration. What happened here? Electron repulsions takes place children. First electron and the second electron. So that is the cause for here. That is why your option D only correct. Next children. Which of the following statement is given below is incorrect? Incorrect statements. O3 molecule is a bent structure, correct only. Here structure of O3 like this. This supports bent structure. ONF is isoelectronic with O2N minus. What is given? ONF. ONF means oxygen atomic number 8, nitrogen atomic number 7, fluorine atomic number 9. Total is how much? 9 plus 7, 16. 16 plus 8, 24 electrons are present. Here, isoelectronic with which one? O2N minus. O2N minus means here 2 into 8, 16 electrons plus nitrogen 7 electrons. Here minus 1 means plus 1 electron. Total 16 plus Here 7, 23. 23 plus 1, 24 electrons. Means both are what happened? Same number of electrons children. That's why ONF, O2N minus are nice electrons. This is correct only. But C option observed here. C option is given. OF2 is an oxide of fluorine. This is given as oxide of fluorine is given. Oxide of fluorine. Not oxide of fluorine. This is called fluorine oxide because of fluorine is high electronic range. That's why it's not a oxide of fluorine. It's called fluorine oxide. But yeah, that is why this is the correct answer, children. Mark is asking incorrect statement. C is the incorrect statement. And one more is given. D is Cl2O7 is anhydride of perchloric acid. Cl2O7 dissolved in water gives rise to HClO4. 2 moles of HClO4. This is called perchloric acid. So what happened? Here Cl2O7 dissolved in water gives rise to perchloric acid. Whereas here removal of water from perchloric acid obtain anhydride of here Cl2O7. So that's why Cl2O7 is an anhydride of perchloric acid. This is also correct. Now the wrong statement is OF2 is oxide of fluorine. So the name is called fluorine oxide. So now here this is correct option, children. 17, C is the correct answer. Next, children. Question number 18. When copper is heated with concentrated nitric acid, so copper CO plus HNO3 and heating with concentrated here. So one of the compound is copper nitrate plus NO2 plus H2O. These are the products of possible, children. Very important. Copper reacts with concentrated nitric acid. Copper reacts with dilute nitric acid. Like that also important. You are asking copper reacts with nitric acid. The product is copper nitrate plus nitrogen dioxide. So that is why option C is correct, children. Next, among the following, the correct order of acidity. So here given also options. What are given oxides? HClO, HClO2, HClO3 and HClO4. Given oxo acids. These are all called oxo acids of chlorine. This is called HClO. Here HCl called hypochlorous acid. This is chlorous acid. This is chloric acid. This is called perchloric acid. Hypochlorous, chlorous, chloric, perchloric. Now your observed oxidation number. Here oxygen minus 2. Here this is plus 1. So 1 minus 2 minus 1 means here chlorine oxidation number plus 1. Like that, here chlorine oxidation number plus 3. Here chlorine oxidation number plus 5. Here chlorine oxidation number plus 7. All are oxidations of chlorine. The central atom is chlorine. Oxidation number changes from plus 1, plus 3, plus 5, plus 7. What happened? Oxidation number increases. That is why here acidic character also increases, children. So now, which is correct answer? 19th. B is correct, children. Next, in which pair of ions both the species contains S-S bond? That is sulfur to sulfur linkage. This linkage is called thiosulfurs. Here one of the compound is called actually Na2S4O6, Na2S2O3. This is called sodium tetrathionate. This is called sodium thiosulfate. Sodium thiosulfate. This is sodium tetrathionate. SS linkage is present in thiosulfur acids. So that is why this is decomposed to what happened? 2Na plus S4O6 minus 2. This is called tetrathionate. This is decomposed to gives rise to 2Na plus S2O3 minus 2. This is called thiosulfate. So there is 4O6 minus here sulfur. Here S4O6. How many sulfurs? 4 sulfurs. One, two, three, four, five, 6. Again, you see observe here, SS linkage is present. This is structure of O. S4O6 minus. Like this, S2O3. So S2O3. Again, it becomes a structure is a SS linkage. This is called thiosulfate ion. This is called tetrathionate ion. So both are having SS linkage is present. So that is why S4O6 minus 2 and one more is S2O3 minus 2 children. So now you can take it as here 20A option. Next children, 21. The species in which the nitrogen atom is state of sp hybridization. The given species, nitrogen atom which is undergoes sp hybridization. Now see children, given compounds are here. One of the compound can take NO2, which is a central atom, nitrogen atom. How to find out hybridization? We are using one of the formula. Total electron pairs is equals 1 by 2 V minus M plus A. V minus M plus A. Using this formula. So now here total electron pairs going on. Here 1 by 2. Here central atom nitrogen 15th group element, that means 5 valence electrons. Here surrounding of number of atoms are here V plus M minus C plus A using this formula children. So here M V means number of valence electrons present in the central atom. M means number of monovalent atoms around the central atom. C is charge of the cation. A is charge of the anion. Only magnitude values. Here V is 5. M is monovalent atoms. Here 0. Cation charge is 0. Anion charge also 0. That becomes how much here? 5 by 2 only. So the formula means here 2.5. Is not correct here. So next we are using NO2 plus can take NO2 plus. That means here 1 by 2. Here 5. Monovalent atom 0. Cation charge is 1. Anion charge is 0. That becomes 5 minus 1. 4 by 2 is equal to electron pairs. So that's why total electron pairs becomes 2. It undergoes hybridization. Sp hybridization children. So that's why 21 no. D is correct. Which is one? D is correct. 21. Next, 22. So next question we have 22 question children. The reaction of white phosphorus with aqueous NaOH gives rise to phosphine with another phosphorus containing compound. The reaction type, the oxidation state of phosphorus in phosphine and other products are respectively. What is given children? White phosphorus, that is P4, reacts with NaOH. It gives rise to products are here phosphine plus here NaH2PO2. These are possible products. Here oxidation of phosphorus is 0. Here oxidation of phosphorus is how much? -3. Therefore the oxidation of phosphorus is how much? Here this is dissociated to formation of H2PO2 -1. That is why here +2, here x -4 is equal to -1. So therefore x is equal to how much here? 2 minus 4 means -2. Becomes +2. Becomes here +1. So then what happened? One is 0 to -3. Again one is 0 to +1. So 0 to -3 is called reduction. 0 to +1 is called oxidation. So now here oxidation changes here. What happened? Oxidation of phosphorus in phosphine and other products. Here phosphine is -3 and one more compound here H2PO2, NaH2PO2. So that is H2PO2 -1. Here 2 hydrogens plus 2, phosphorus X, 2 oxygens -2 minus 2 minus 4 is equal to -1 charge. So here oxidative phosphorus children +1 only. So they are given option, so there is no suitable answer. But you can take here -3 and +5. This also a disproportionation the option. 0 to +1, 0 to -3. Same will make it undergoes oxidation and reduction takes place. That's why children here in option C change. Option C is given -3 and one more can change the option here +1 children. Because of it is a disproportionation reaction -3 and +1. Because here actual compound is H3PO2. H3PO2 is a monobasic acid. But here remove of hydrogen atom H2PO2 -1. 2 hydrogens plus 2 plus X. 2 oxygens 2 into -2 -4. Charge is -1. So therefore what happened here? 2 minus 2 4 means -2. -2 becomes +2. +2 minus 1 it becomes +1 only. Next children, which of the following compound has PP bond? So which is PP bond here? Which is PP bond children? Means phosphorus linkage. So here phosphorus linkage is possible here. H4P2O6 only. The question number 23. Here P and P. Here OH. Here OH. Here OH. Here OH. 1, 2, 3, 4. Double bond O. Double bond O. So this is called PP linkage is present in the compound H4P2O6. But one more compound is given H4P2O7. This is a POP linkage. Next, 24. Match the interhalogen compounds of the following geometry children. We are given XX dash. XX dash is about shape is linear. The best example that they class here CL. Here Cl and F. Here chlorine surrounding by 3 lone pair of electrons. One more is about XX dash 3. This is about shape is T shape. So here X atom surrounded by here lone pair of electrons. Here surrounded by XX3. Fluorine, fluorine and fluorine. Here surrounded by lone pair of electrons. So that's why F shape is a T shape. X 5. X dash 5. Then take example here, best example here. CLF 5. X dash 5 is about the square pyramidal children. This is square pyramidal. Can take example here, CLF 5. Fluorine. Yeah, fluorine. This is fluorine pyramidal electron. CLF 5. X dash 7. Example here, IF7. This is about pentagonal bipyramidal children. So now X dash is linear shape. That is all. X dash is a linear shape. So that means X dash means so. A is 3. A 3 is possible for two options are there children. Next you can see X dash 3 is about to T shape. So means so B is 1. A3 B1. A3 B1 is only one option is there. That is can choose as here. Option A is a correct answer children. Okay. So these are about the classworks assignment children. Today we have discussed. So next there is any doubts in the homework assignment, ask in the doubts clarification. Okay children, this is one of the assignment in P block elements. Second assignment was completed. Next one more assignment discuss about the later.